Hello friends, this is Kishore Kumar Vaja. In this tutorial, you are going to learn about basic concepts about videos in OpenCV programming. If you like these tutorials, please subscribe my channel for the upcoming tutorials, and also subsequent tutorials will be informed to you. Let's see the agenda first. First, we will see how to capture a video from camera. Next, that captured video conversion to gray color video. Next, we will learn how to resize the video window. Next, how to check whether the camera is initialized or not, and learn some video features through property identifiers. The second point is we will learn about saving a video frames into a folder. Third point, we will learn how to play a video from file. Fourth one, we will learn how to get video frames as image files. And lastly, we will see video animation using OpenCV programming. Let's start the session. First one is capturing a video from camera. To capture a video from camera, you need to create a video capture object. This is the syntax for video capturing. cv2.video capture of 0. Here 0 is an argument, that is the input camera. In my case, my laptop web camera. We have more than one camera. You can pass the arguments as 1, 2, 3, just like this is the index, like that. If you want to play a video, you have to give the argument just like this, that video file name. Here test.mp4 is the video file name that is given here as an argument to the video capturing object. It reads frame by frame. After that, you can capture frame by frame. Actually, video is a sequence of frames. Its speed is measured in frame rate, that is frames per second. If you take frame rate as 30 frames per second, it plays 30 frames in a second. So you can consider it as 30 images per second, so that a frame is an image file. In a 1 minute of video with 30 frames per second rate, you will have 60 seconds into 30 frames, that gives 1800 frames per second. Now we will see the programming part to capture a video from camera. To capture a video, we need to import CV2 module. Next, we need to create a video capture object by using cv2.video capture of 0. Here 0 is the my webcam index, that is device index. Next, after capturing that video, we need to read it frame by frame using this cap.read function. After reading frame by frame, we will show it in a window by the name video. After completing everything, we need to release that capture. We need to release the video cam, and finally we close all the windows. Here, first we capture a video through the function cv2.video capture function. It is assigned to the variable cam. After assigning that video, we need to read that video frame by frame. For that, we are using here while loop to read the video frames frame by frame. So while true, that means if the video camera is open, we are reading frame by frame using this cap.read function. This cap.read gives two values here. First one is ret, that is return value. That means it is a Boolean value actually. If frame is read correctly, it will be true. Next value is frame, that is the video. We are reading the video frame by frame. After reading that video by the name frame, we are displaying it in a window named video. This is the window name using this function cv2.imshow function. Next, if you want to read the video, you have to press Q. For that, we wrote the like this: if cv2.wait key function double equal to ord of Q. When you press the Q key, the window will be closed. Next, video cam will be released using this cap.release function. And finally, we will close all the windows using this cv2.destroy all windows. Now we will see the output. Here the window name is video, which we have given. This is video cam output. We are reading frame by frame. Now by pressing Q, we will quit the window. See how to convert this colored video to the gray color. We are going to convert that colored video into gray color using this function cv2.cvtcolor. First argument is the frame, that is which we are reading frame by frame video here. Next, cv2.color underscore bezier to gray. This is a flag actually. Here we are converting bezier colored video into gray. This output is assigned to the variable gray here. Next, we will see the output of the gray color video using cv2.imshow. Here we have given the window name is gray video. This is gray, that is the variable gray here. We are going to see two outputs. One output is color and next one is in gray color. See the output. See these two. First one is the colored video, that is window name is video, and second one is window name is gray video. This is in gray color. Like this we can convert the video into gray color. Now I am going to press Q to close that video and capture it. Now we will take a gray video here. I am going to resize that window actually. First we will see the window as it is. Here this window, I cannot resize this window. If I want to resize this window, if I observe here, if I want to resize this window to the window size, you have to use this function cv2.named window. Here video is the window name gray video. Second one is a flag, that is cv2.window underscore normal. This means you can resize the window. We will see how it will. We can resize this window like this. We can resize as per our requirement. But in earlier case, we cannot resize the window. But using this cv2.named window and using this flag cv2.window normal, we can resize the window. Now we will see one more flag here to size. It gives the output like this, but here you cannot resize using this flag. Then you can resize your window as per your requirement, just like this. Okay. Now we will check whether the camera is opened or not. First initialize the camera using cv2.video capture of 0. Next use the cap that is open. Here it returns true. That means our camera is open. Now read the video by frame using this cap.read function. Here first value is written, that means it returns true. That means our camera is open. Now next frame, that is our video frame by frame reading here. This is the frame by frame. This is the frames. Here the data type is unsigned integer 8 bit. Now we will check whether the camera is initialized or not using the function cap.isOpen. Here first we import the cv2 module. Next creating video capture object and assign it to a variable cap. Next using while loop we are reading frame by frame. we are using cap.is open. Actually, it checks whether the camera is opened or not. If camera is open, then it is true. Then it will read frame by frame. Otherwise, it cannot read frame by frame. For that, we are using in while loop cap.is open. First, we are capturing frame by frame. That is, we are reading it, and next it is converted to gray color. It is assigned to the variable gray here, and that output is given to the window gray video, and we will see the output. If camera is open, then only the camera captures the video, otherwise it cannot capture. Now we will see video capturing features using the functions video capture get ID, that is property ID ranging from 0 to 18. First we will read cap.get of 0, that means it gives conversion of video file in milliseconds. Next cap.1, it gives 0 based index of frame rate to be decoded and captured. Next cap.get of 2, it gives the relative position of the video file. 0 is the starting and 1 is the end of the film. Next is cap.get 3, it gives the width of the frames in the video stream, that is 640 width here. Here cap.get 4, it gives the height of the video, here 480. Next cap.get 5, it is the frame rate, here 30 frames per second speed, here it gives. Cap.get 6, here, this is the 4cc codec, 4 character code of codec. Cap.7, it gives a number of frames in a video file using this function. Next cap.8, format of the mat objects returned by retrieve function. Cap.get of 9, it is the backend specific value indicating the current capture mode. Cap.get of 10, it gives the brightness of the image only for cameras. Cap.get of 11, it gives the contrast of the image only for cameras. Cap.get of 12, it gives the saturation of the image only for cameras. Cap.get of 13, it is the hue of the image only for cameras. This function using. Cap.get of 14, it is the gain of the image only for cameras used. Cap.get of 15, it is the exposure only for the cameras we have to use. Cap.get of 16, it is a Boolean flags indicating whether images should be converted to RGB. Cap.get of 17, it is the not currently used, so actual balance. Cap.get of 18, it is the rectification flag for stereo cameras, only supported by simple program on property identifiers. In this program, we are going to get the features of video through the property identifiers. For that, we will take input video. Here test.m4 is a 20 seconds duration video. I'm going to play and see the features of that video properties using this function cap.get. First, I'm going to capture that video file test.mp4. Here it is, we are reading frame by frame by using cap.get here. Next, we are going to show that video to the window named that is video. After completing that video playing, we are going to get the property identifiers of that video in the output. We will see. Now execute the program. See here, the video is playing. We will see the video features, its property identifiers. See here in the output. First one is cap.get. Actually, this is current position of a video file in milliseconds. Second cap.get of 1. This property identifier gives 0 based index of frame to be decoded or captured. Next, cap.get of 2. It gives the relative position of the video file. If there is 0, it plays from the beginning of the video. Cap.get of 3. This is the width of the video file. that is 1920 is the width. Cap.get of 4, here 1080 is the height of the video frames. Next cap.get of 5, here 30.0, that means it is its frame rate, frames per second, 30 frames per second it's playing actually. Next cap.get of 6, this is 4cc, 4 character code of codec, this is used in this video. Cap.get of 7, this is the number of frames in that video. In that video 615 frames in 20 seconds duration of video. So I'm here showing only few properties essential. Those are we got from this program. Now we are going to see how to modify the width and height of a video frames. First open the Python terminal. Next import the CV2 module. Now initialize the video cam through video capture object. Now see the current width of the video frame is 640 and current height of the video frame is 480. Now we are going to modify this width and height of video frames using cap.set of 3,320. That means we are going to modify width of the video frame first using this cap.set. Next we are going to modify height of the video frames using cap.set of 4,240. Here we are going to modify the height from 480 to 240. Now we will check the current width and height of the video frames. Cap.get of 3. Here the 320 is the new modified width of the video frame. Now we will check the height of the current video frame rate. It is modified to 240, so that we can modify using this cap.set function. Like this we can modify the height and width of the video frames resolution. To save a video, we need to create video writer object. For that we need a codec here, that is 4cc. Using this function cv2.video writer underscore 4cc of divx. This is 4-byte code used to specify the video codec. The list of available codecs can be found here, www.4cc.org/codecs.php. Actually it is platform dependent. I am using Windows laptop, for that I am using divx. If you are using the Fedora, Linux, some other, you can use divx, xvid, mvpz, x24, etc. This is the syntax for saving a video. Here cv2.video writer of output.eava. This is the output which we are going to write. Force is the codec here. This is codec, and 30.0. This is the frame rate of video. Here I am using 30 frames per second. Next 640, 480. This is the video size, that 640 by 480 resolution. Now we will see the program. Now we will see the program for saving a video to a file. First we need to import the required module, that is CV2 module. Next we have to create a video capturing object using cv2.video capture of 0. Here 0 is the webcam stream here, that is assigned to the variable cap. Next we need to create a video writer object, that is a cv2.video writer function, that we need to use a codec. Here I am using divx. For that I am using this function cv2.video writer underscore 4cc of divx. This is the codec we need to use here. Next that codec is used in video writer object here. First one is the output.avi. This is which we are going to save the file to this, which we are going to save the output to this output.avi file. Next this is the codec 4cc. Here I am using divx. Next 30.0. This is the frame rate, 30 frames per second. Next 640 by 480 is the resolution of the video. This is a video writer object. To capture the video frame by frame, we need to use while loop. For that we have used here cap.is open, that is if the camera is open, then this program will execute. Here cap.read is the input stream of my video that is reading frame by frame. Next I'm going to flip the video 180 degrees. That I have used here c2.flip function. Here frame is the input video frame that is taken and flipped to 180 degrees. Here that output is going to convert gray color using this function cv2.cvd color of frame comma cv2.color underscore VG2 to gray. Here we converted that input video. That video means here the flipped video, which is going to convert into gray color. Next that gray colored video is going to write the function video writer object. It sends the output.avi file, and that output file we are going to show in the video in the window name gray video. Yes, here we will see in that window gray video. After that, to quit the window we need to press Q. After everything is done, we have to release input video camera. Next output file. Next, and close all the windows. Now we will execute the program and see the output also. Now here my window name is gray video. My video is flipped. This video I am going to save in the file name output.avi. Now I am going to close this window by pressing Q. Now we will see the file output.avi. This is the output.avi file. Here we will see this is my output file. Okay friends, now we will see how to play a video from the file. It is same as capturing from camera. Just change camera index with video file name. This is the syntax for that. So we do that video capture of. Here earlier we have given 0 for our device index, that is webcam, but here the video file name, that is test.mp4 is given, which we are going to read and play. Now we will see the code. First we need to import the CV2 module. Next we need to create video capturing object. Here the argument is given test.mp4, that we will see that test.mp4 video first. This is test.mp4. This is my test.mp4 video file. This is I'm going to read, and so here that file name is given test.mp4. So this argument video capture. Next we need to read it frame by frame, that video using this cap.read, that is going to display the named window video here in using this flag cv2.window underscore normal. It is, if you use this flag, the window can be resized as per our requirement. Now we will see the output. See here, this is the .mp4 file is playing in window named video. We can resize also as per our requirement using this cv2.window normal flag. If you want to quit, just press Q. You can play it to speed also if you want, by changing this wait key. Also, while displaying the frame, you can change the video playing speed by changing here the argument wait key. Now we will see how it moves. It moves very fast. Okay, now we will give 1, then it plays very fast. Observe here. Okay, if you give 50 milliseconds, then we'll see how it moves very slow. The video playing is depending on this wait key argument. rescue. If we want to play it smoothly, we'll give 27. No, the video is playing very smoothly. Okay, now rescue. Now we will see how to get video frames as image files using video capture object. I'm going to read the input video as image files. Now we'll see the program code. This is the code for video. This is the code. In this code, I'm going to capture a video to input video. From that, I'm going to get image files. First, we need to import required packages. Those are CV2, NumPy, and OS. These are first I need to import these modules. Next, I need to create video capture object using this CV2.video capture. Of 0 is the index of my webcam. Next, the input video. After reading that input video, I'm going to collect all the images in a folder that is named data, which is going to create using this function os.path.edges. If it is not, then it create that data folder using os.make dir of data. After that, we need to read it frame by frame using cap.read. Here, current frame is equal to 0, which is going to initialize it for that each frame to be read and write as an image file. For that, I have used current frame equal to 0. This is initialized here. Next, the input video is converted to frame by frame. That frame by frame video is converted into .jpg format using this line of code. Name equal to data frame. Data is the folder name which I have already created using this os.make dir function. Frame is the input video name. The string current frame. Current frame is initialized in the beginning. That is first 0. That file format is .jpg. Next, it prints creating that file name. Next, that input video is right to the name. Next, to stop duplicate images, I have used this current frame plus equal to 1 to stop the duplicate images. Next, the input video I am going to display using CV2 data I am shown in the named window color. We will see the output. This is my input video, which I am going to collect as image files. Now I am going to press Q to close the window. Now we will check the folder name data in my current directory. This is the data folder I have created using that os.make directory function. Here, frame 0, 1, 2, 3. This is the name I have given here actually. See here. This is the name given. Data folder, file name is frame plus string current frame, that is 0. First one is initialized 0, next one is 1. Similarly, next the format is .jpg, frame 0.jpg, frame 1.jpg, frame 2.jpg. These are I have collected as a image file. The input video is collected as image file. Here 435 images are created just like this. You can observe each frame is collected with a 30 frames per second of speed. Now we will see video animation using OpenCV. For that, first we create a nice background video. Next, we will create a red circle which is moving on the nice background video. For that, we are going to use the codec MP42. Using the video writer object, we are going to create a video animation. Now we will see the code. See here friends, first import the required packages numpy and cv2 modules. From that we are going to import video writer and video writer for cc functions. First we create a 1280 width and 720 height resolution video and frames 24 frames per second frame rate. The video length is 10 seconds here. For that, first we create a video writer object using this codec MP42 and write it in file. That file name is nice.avi. This is the nice background video file name, and forces is the MP42 video codec. Next, frames per second here 24 frames per second. We are using frame rate, width and height 1280 by 720 resolution. For that, we need to use for loop here. The total length of the video is 10 seconds. We have taken into each 24 frames per second. That means 24 into 10 is the 240 frames. That is given here total range. Here we have used random dot rand in it. First one is 0 to 256 in the range. We are going to take the values. Next, height, width and 3. This is the color channel. Height is the 1280, height is the 720, width is the 1280. This is the 3 is the color channel. Color nice video. And we are going to take data type as unsigned integer 8 here. Next, that output is going to write to this name video data write a frame, that is going to write to nice.avi file name. Now we will see the output. Okay, now it is processed. Now finished the output video. We will see the output file nice.avi. Observe here. See, this is a nice.avi. I have created the 1280 by 720. Now we will create a red color circle ball on that nice background video. For that, we imported the required module CV2, NumPy, video writer for CC, and created that video with 1280 by 720 frames, 24 frames per second. Total video length is 10 seconds, and the circle radius is 150 pixels. I'm going to create video writer object using this 4cc codec M42. The main text I have taken that radius. Here I am created the red color circle ball using this function cv2.circle. Frame is the window that is input video. Paint underscore x comma paint underscore h is the here paint x is the this is the circle coordinates. Paint underscore x and paint underscore h is the coordinates of the circle. We have given radius, we have given 150. Next, this is the color of that circle, that is red color. Next, -1 is the circle is filled with that red color. That is going to write into the circle underscore nice.avi file. We will see the output. Observe here, after completing it finished. So we will check the circle underscore nice.avi file. See here, this is circle. Okay friends, in the next tutorial we are going to learn how to draw different geometric shapes using OpenCV. In that, first we will create a black image. On that image we are going to draw line, a circle, a rectangle, an ellipse, and write some text on that image. We will going to learn in the next tutorial. If you like this tutorial, please subscribe my channel for the upcoming tutorials, and also subsequent tutorials will be informed to you if you subscribe it. Thank you for watching, friends. This is Kishore, just signing off.